Okay, we're in section 36 now. So I'll certainly go to the whiteboard with this. I want to point out there's a list of integrals you should know. Now, certainly some are more important than others. When I say that, they're going to pop up more often, and you'll see them more often. You'll certainly recognize these. So this over here is all about recognition, and I will go through that with you. All right. Now, after recognition, the next technique we're going to be talking about is U-Substitution. All right. The point about U-Substitution is that you're going to get integrals that are not recognizable. However, if you redress them, they will look like the one you should be recognizing, and that's called U-Substitution. This is probably the simplest technique after recognition. So recognition is your first goal. Your second goal is to use U-Substitution to see your recognition, all right, to see an integral that you recognize. All right, we'll go through examples of that, of course. This initially is just simply a discussion of it, all right? When we go to the examples, we will do the examples with the understanding that we're using U-Substitution for the ultimate goal of being able to recognize an integration. So we go to the whiteboard, and I'm going to share with you. Okay, so let's talk about recognition. Okay, I can't say it enough times, recognition is the best technique. If you can recognize something and know what it is, that's good. Otherwise, it's going to take, a lot of questioning about what it is, who it looks like, yada, yada, yada. Right, I'm going to say this is a partial list of integrals that I think you should be familiar with. Now, granted, some are probably more important than others, and we've discussed these antiderivatives before. For example, if you look at the list, some have stars next to it. Some have like 100 stars, some have 50 stars, some have an infinite number of stars, some have 25 stars. I know it's a long list, by the way, and some have three and 2 stars, all right? So what I'm going to do over here is I'm just going to talk about the most important one that you should recognize. This is the single most important integration to recognize. If you see this integral, you should immediately write this down. All right, now what's the next one? I'm going to say the power rule. If I see this, I would immediately write that down. All right, then let's go to the other ones. The other one to recognize is this one over here. And these are ones that we've covered before. So someone says, I don't remember covering that. We did in the antiderivative section. All right, I'm going to keep going through the list. Certainly I'm seeing these guys over here. You should recognize this. You should recognize this. It's a pretty short list at this point. Let's keep going. And I'm going to say you should recognize these two over here. So soon I'm going to say, well, what about the other ones you listed? The only ones I highlighted, let's see, that's 2 on that page, right? On this page, 1, 2, 3, 4, 5. Now, certainly someone's going to say, do I need to memorize this? I'm going to say the big deal for me is not memorization, is understanding that these are antiderivatives, and they're pretty easy to check. How do you check them? Just take a derivative of it and make sure you get the integrand back. So this is important, that you're really not memorizing, you're really understanding differentiation and its relationship to integration. Now, these other guys over here, I will point this out to you. A lot of times when I'm looking at things, I can't remember these things. So I want to go through what I would do if I were seeing these integrations over here. So if I were seeing number 4, what I would probably say to myself is, it must be related to the derivative of a to the x. So what I would do is this. I would say, I know how to take derivatives. Now I realize what someone's going to say, I don't remember that derivative either. Well, the way we did that, we took the natural log of both sides. And what would I get over there? X, ln a. I would use implicit differentiation. That's 1 over y, dy, dx equals ln a, dy, dx, which is my goal. I'm good at differentiation. Multiply both sides by y. Well, y is just a to the x, ln a. So then you have to start to think, what function would differentiate to a to the x? Well, that's pretty clear to me. It's a to the x, right? And then what do you have to do? Whoops, I didn't mean to put that dot there. Well, if you differentiate that, what would you get? You get ADX ln A. So we need to divide by ln A plus C. Right. I want to check it again. How do you check it? The way to check this is d dx of this. This is going to prevent me from having to memorize a lot of things. Well, I just did the derivative. So what do I know? The derivative of a to the x is ln a to the x, and I got ln a as a constant, plus 0. This cancels off. I get the integrand back. So I'm pretty comfortable that this one also is certainly recognizable. I've seen it before. Am I going to memorize that? No. Now this one over here, I want to point out the way I'd recognize this. I think to myself, what differentiates to secant squared? And I'd say, oh, I'm sorry, maybe I misspoke there. Did I? I think I said, yeah. What differentiates to secant squared? What differentiates to secant squared? I'm hoping you have some recollection that what goes here is the tangent of x, all right? Likewise, look at this one over here. What differentiates to the cosecant? And again, we're hoping you have some recollection. What would that be? Well, I know that the derivative of cotangent is minus cosecant squared, so it's going to be minus cotangent. Again, thinking is really important. This one over here, I'll be honest with you, for a lot of students, this one's a little bit difficult. I'm not sure why, but d dx of something will differentiate the secant. So really what are you recognizing? You're recognizing derivatives we've done before, and that's a derivative of secant. All right, I'm not asking you to memorize. I'm asking you to reason. Right, likewise over here, the derivative of my cosecant is going to be cosecant cotangent. This one, I'm going to say, I think this looks tough. I'm going to say so tough that I'm going to say, I don't think anyone would be expected to either memorize that or reason through that. However, when you get to Calc 2, you'll be able to derive this. I also believe this one is tough. However, I believe when you get to Calc 2, you'll be able to get that one as well. So I'm going to say tough, tough. I wouldn't expect anyone to remember that. Now I'm going to look at tangent x, and I want to introduce the concept of U-substitution for this problem over here. Now granted, this is new. I realize for a lot of students, this is going to be difficult. It's the first step though. So I'm going to write this down. What's tangent? I'm going to write it as sine x over cosine x dx. And what I'm going to tell you over here is that I don't recognize this guy. Now someone says, oh yeah, you do, it's right over here. You know the answer. No, not really. Someone told me that. I don't know if that's true. I could differentiate all kind of stuff. What I'm going to say over here is that I want to turn it into something that I recognize. So what I'm going to do is a concept known as U-substitution. We'll talk about this on the next page, but I just want to do an intuitive understanding of U-substitution. So I'm going to say U is equal to cosine of x. Now, if you made a substitution over here, what you'd see, you can put a star here, because again, might be a bad thing to do. What would you get on bottom? Well, cosine of x is just U. But then what do I see? I see this thing over here. And then I wonder, what is this thing over here? Well, what I'm going to do is use a differential. Du would equal minus sine x dx. So I'm starting to recognize that minus du is the same thing as sine x dx. Well, let me write that down. Minus 1 du. That's all I'm putting down. So what I do, I made a substitution. Here's my problem. Do I recognize that? I think so. Right, that's in one of the lists. That's in the list you should know. What's that going to be? Minus the natural log of the absolute value of u plus c. Traditionally, we don't write that down because I didn't want to know what u was. I want to know what the x integral is. So what do you get over here? What's u? It's cosine. Let me write this over here. All right, I want to go to the answer. I'm sorry, not the answer, but what they say it is. They say it's this over here. And someone says, oh, you got the wrong answer. Let's go through it. Something about logs. What do you do? Natural log absolute value, cosine x, is going to be the -1 plus c. What's cosine to the -1? It's going to be secant. And that's why we wrote that down. All right. Granted, this is new, and you might be scared by this. Hopefully, over time, as we start doing examples, it becomes easier and easier and easier to do. So I'm going to say over here, although this looks strange to you, it can be done. So I'm going to say it can be done. Again, this is new to you. We'll go through more examples later. Let's go to the next page. And again, it's recognition. I'm going to say over here, well, you know what? You just seen me do something, and I'll put this one over here. Let's write this one down, and let's see if we can do that. What's cotangent? And again, when you took Math 110, your teacher probably told you, rewrite in terms of sines and cosines. So it's going to be cosine x over sine x. Let's see, that would be dx, right? Cosine over sine. I'm going to do my U substitution now. U equals sine of x. What's du? Well, let's see. It's going to be cosine x dx. I'm seeing this in the problem. I'm using a star to indicate I'm going to the land of u's, but I do need to return to the x at some point. So what do I say? Well, I do see this, and I do see this. I'm just going to make a substitution now. What do you get? 1 du over u. Do I recognize that guy? I sure do. Just like the last guy. ln, absolute value of u, plus c. Again, tradition is we go back to the x in the problem. Natural log of what? Of sine, right? Let's see if we got it right. Wow, we got it right over here. All right, now in Math 121, we no longer cover hyperbolic functions. So you don't need to know these. So no need, at least at ECC, no need, all right? These over here, I'm gonna point out they should be recognized. For example, you should recognize that the derivative of arctangent is this, and you should recognize the derivative of this is this over here, all right? Now let's formally talk about U-substitution. And it says over here, all right, when recognition fails. And I'll be honest with you, most integrals, recognition will fail. You will not recognize the integral. Now, when I say, whoops, sorry about that. When I say recognition fails, I mean you're going to look at an integral and you're going to have no idea, but it's going to fail you. But recognition is the single most important method of integration, but it's going to fail. Recognition fails almost all the time, right? When it fails, what you're going to try to do is strip it of its costume and make it look like something you recognize. And how are we going to do that? We're going to do it with U-substitution. So really, what are we looking for? In the problem, we're looking for some function in the problem whose derivative is also there. So let me go back over here and tell you what I did over here. I looked at cotangent. It was unrecognizable to me. What did I do? I saw in the problem a function whose derivative was there. I saw that. And I wrote that down. So I recognized the function, and then I wrote down the differential. All right, I start to recognize it. All right, what happens then? I see an integral I should recognize, and then I do the integration, and then I make my substitutions. All right, this is tough though, and I'll be honest with you. Someone says, "Well, I don't even know what to look for." Let me repeat this: you're looking for a function in the integrand whose derivative is in the integrand. All right. So someone's going to say this is a lot of work. Here's the deal. We can always check. So when I say we can always check it. All right. The problem for a lot of students though is recognizing what the U is and then writing down the differential. All right. Let me put out what I mean by that. We're going to say U is some function contained in the integrand and then writing down the differential. So I'm going to be saying this over here. U is some function contained in the integral. And then I'm going to write down du is g prime x dx, and that's also in the integral. And then we need to make our substitution. What would you get over here? If I did this one over here, it would be f of, well, I said g of x was u. And what I say g prime dx was du. So what I do, I rewrote the integral in terms of a function of u, differential of u. That's my goal. All right. So bottom line, once we do that, we have to go back and make our substitutions. Next up, we're going to do plenty of examples. Now, I realize for students, initially, they don't know what the substitution is. So we tell you. However, the goal isn't for somebody to tell you the substitution. The goal is to show you a show and tell where eventually you say, hey, I'm going to make my own substitutions and I'm going to try. Some are going to be tricky. Here's the deal. These problems have been carefully written to work as advertised. What are we advertising here? U-Substitution and recognition. That's what we're doing. All right. Okay, examples come up next. Thank you for your attention.